Dear students, let us solve a question on continuous random variables. A random variable capital X has probability density function PDF small fx is equal to 1/5 when x lies between 1 and 2 fx is equal to 1/5x minus 1/5 when x lies between 2 and 4 and fx is equal to 0, otherwise means that whenever the value of x is less than 1 or the value of x is more than 4. Find the cumulative distribution function CDF. So let us see the solution. Now when we are finding the CDF, we will consider 4 pieces and one by one we will work on each piece. The first piece will be what happens when x is less than 1. Second piece will be what happens when x is between 1 and 2. The third piece will be what happens when x is between 2 and 4. And the fourth piece will be what happens when x is more than 4. So let's start with the first piece when x is less than 1. Or we can say that when x is less than 1 and greater than minus infinity. If I see the number line minus infinity, 1, x is somewhere in between minus infinity and 1. Using the definition of CDF, capital Fx, definition says it will be minus infinity to x ft dt. And because x is less than 1, so it falls in this category. So the value of PDF will be 0. So this ft, the PDF, becomes 0. And integration of 0 will give us 0. So first part is done. Let us go to the second piece. what happens when x is between 1 and 2? Again, let's draw the number line to visualize. 2, 1 and x is somewhere in between 1 and 2. And here we have our minus infinity. So when I am finding the CDF, definition says minus infinity to x ft dt, and this integration minus infinity to x will be broken into two parts, minus infinity to 1 and then 1 to x. So we will get minus infinity to 1 plus integral 1 to x. Minus infinity to 1, it falls in this category. The value of PDF is 0. So this will be 0 dt. 1 to x, it falls between 1 and 2. So it falls in this category. Between 1 and 2, the value of the PDF is 1 by 5. Let us integrate. The first integral becomes 0. Integral 1 by 5 dt will be t by 5 over the limits 1 to x. Now putting the upper limit t is equal to x, we get x by 5 minus, putting the lower limit t is equal to 1, we will get 1 by 5. Now let's go to the third piece. When x is between 2 and 4, to visualize we will draw the number line. Minus infinity to 1, then 2 and then 4, and x is somewhere between 2 and 4. Now let us find the CDF fx. By definition, this is minus infinity to x ft dt. Now this integral I will break from minus infinity to 1. In this case, the value of the PDF will be 0 plus second integral will be from 1 to 2. In this case, the value of the PDF will be 1 by 5 plus the third integral will be 2 till x. X lies between 2 and 4. X lies between 2 and 4. The value of the PDF will be x by 5 minus 1 by 5. So here we have t by 5 minus 1 by 5 dt. Now let us integrate. So first integral will become 0. Second integral will become t by 5 over the limits 1, 2. And the third integral will become t square by 2 multiplied by 5, that will be 10, minus t by 5 over the limits 2x. When I put t equal to 2, I will get 2 by 5 minus, when I put t equal to 1, I will get 1 by 5 plus, when I put t equal to x, I will get x square by 10 minus x by 5 minus, when I put t equal to 2, I will get 2 square, that will be 4 by 10 minus 2 by 5. After simplifying, I will get x square by 10 minus x by 5 plus 1 by 5. Now let us see the fourth piece. What happens when x is more than 4? To visualize, let us draw the number line. Minus infinity, 1, 2, 4, and x is somewhere greater than 4. So let us find the CDF. Fx will be minus infinity to x ft dt. Now this integral I will break from minus infinity to 1. In this case, the value of the PDF will be 0 plus second integral from 1 to 2. In this case, the value of the PDF is 1 by 5 plus third integral 2 to 4. In this case, the value of the PDF is x by 5 minus 1 by 5. So we have t by 5 minus 1 by 5 plus fourth integral, integral 4 till x. So when x is greater than 4, then also the value of the PDF is 0. So the first integral will become 0. Second integral will give us t by 5 over the limits 1 to 2. This integral will give me t square by 10 minus t by 5 over the limits 2, 4, and the last integral also becomes 0. Let us simplify further. When I put t equal to 2, I get 2 by 5 minus, when I put t equal to 1, I get 1 by 5 plus, When I put t equal to 4, I get 16 by 10 minus 4 by 5 minus, when I put t equal to 2, I get 4 by 10 minus 2 by 5. And when I simplify, this will give me 1. Now let us write the final answer. That is the CDF capital Fx. The first piece we have discussed, when x is less than 1, capital Fx will be 0. Second piece we have discussed, when x is between 1 and 2, capital Fx will be x by 5 minus 1 by 5. When x is between 2 and 4, we have calculated capital Fx will be x square by 10 minus x by 5 plus 1 by 5. When x is greater than or equal to 4, we have calculated that capital Fx will be 1.